Welcome back, everybody. This is our video solution to problem 1 from Quiz 5, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. In this problem, we're given a vector space V over a field F. Hey, what a surprise. And a list L consisting of 4 vectors, V1 through V4. These are vectors in V, and we know that this list spans V. Right? So here you can see the span of the list L is equal to V. We're then given another list, call it L prime, where we're taking combinations of the V1 through V4. So, well, actually the first V1 is actually the same thing, but then now you're adding V1 to V2, then you're adding V1 to V2 to V3, and then V1 to V2 to V3 to V4. And our goal is to show that even though we've done all this manipulation, the span of this new list, L prime, is still equal to V. All right, so how we want to go about doing this? In principle, we could start by saying, well, let V be an element of V and show that we can write V as a linear combination of all these guys. But that feels like a lot of work. Instead, we want to use this same result that we've used before, which is if we already have a spanning list, and we do, V1, V2, V3, V4 spans V, all we need to do is show that this spanning list is in the span of L prime. Because once we can get V1, V2, V3, and V4, we get everything else as linear combinations of those. So it suffices to show that V1, V2, V3, and V4 are all in the span of L prime, since this implies, well, now we'll leave a little space. This implies that the span of V1, V2, V3, V4 is contained in the span of L prime. And we already know that V is equal to the span of these vectors. And, of course, the span of L prime is contained in V. And so since we start and end this chain with V, we must have equality all along the way. All right, so this is what we have to get at. Right? Why is V1, V2, V3, V4? Why are all of those elements or all those vectors inside the span of L prime? Well, all we have to do is show that we get them as linear combinations. And one of those is very easy. V1 itself. We already know V1 is in the span of L prime because V1 is in L prime. Right? It's just 1 times V1 plus all the rest. So V1 is in L prime, so that implies V1 is in the span of L prime. All right, we just write it as V1 equals 1 times V1 plus 0 times, well, all the rest of the stuff. All right, I'm not going to copy it. All right, so what about V1 plus, or how do we get V2? Well, I claim V2 is not in L prime. That's very obvious. It's not one of those 4 vectors. But V2 is in the span of L prime because I can write V2 is equal to what? Well, I'm going to take -1 copies of V1 and add that to 1 copy of V1 plus V2. And we see what we get. If of course, this 1 copy doesn't really do much. I have -1 V1 and 1 V1. Those cancel. And so I'm just left with V2. All right, so V2 is in that span. How about V3? Well, I claim V3 is also in the span of L prime. Why? Well, I notice here I have now this V1 plus V2 plus V3. I'm going to take 1 copy of that, and then I'm going to get rid of, let's see, if I have V1 plus V2 and I negate that, so let's see, we'll have no copies of V1, I just won't even write it. If I have -1 copies of V1 plus V2, and I add that to 1 copy of V1 plus V2 plus V3, oh, the -1 copy and the 1 copy of V1 plus V2 cancel, and I'm just left with 1 copy of V3. Okay, and so finally V4, well, at this point you probably can guess what's going to happen here. I'm just going to take the 3rd and the 4th vectors in my list L prime. I'll take -1 copies of V1 plus V2 plus V3 and add it to 1 copy of V1 plus V2 plus V3 plus V4. So -1 times v1 plus v2 plus v3. And then I'll cancel that with 1 copy of v1 plus v2 plus v3, and then I get this extra v4, which is the only thing left, which is exactly what I want. Okay, and there we go. So that's going to finish the proof. All right, hope this is helpful. We will see you next time.